Today we're going to be looking at special right triangles. It's not something that's part of the unit circle stuff that we're talking about right now, but it's a review from geometry, and I think it'll help us understand the unit circle a little bit better. So let's start off with this special right triangle, and we're looking at a 45, 90 degree right triangle. So what we start off with is a square. So this is a square. Now let's say all the sides are length x. Alright, what we also know about squares is that we have right angles in each of these corners. Now let's take this square and split it in half diagonally. So we're going to just chop. We're going to chop our square right down the middle at a diagonal. Now let's take a look at this part, this section that we just created. So if I redraw this, now we have a triangle. We know it's a right triangle because we have a right angle here. We also know that these are both the same length. Each of the shorter sides of our right triangle are x. Now, what we're trying to do is we're trying to find how long the hypotenuse of this triangle is. And remember, the hypotenuse is always across from the right angle for any right triangle that we have. It's going to be the longest side. All right, so let's do some algebra here. All right, so anytime we have a right triangle, if we're trying to find one of the sides, we can use the Pythagorean Theorem. As long as we know the length of the other two sides. All right, so the other two sides here are length x. Now remember, our Pythagorean Theorem is a squared plus b squared equals c squared, where the a and b are the shorter sides. And then c is the hypotenuse. Alright, so let's go ahead and start figuring this out. So the shorter sides are the x's. So we're going to have x squared plus another x squared is equal to, well, we don't know. So we'll just say c squared. We're trying to find out how long that length is in terms of x. So if we're solving this algebraically, we notice that x squared and x squared are like terms, so we can definitely add them. And then what we're going to do to solve for c is we're going to take the square root. Now x squared is a perfect square, so that the square root of x squared is going to be x. So we have our x. The 2 here is not a perfect square, so we're going to leave that in the in the radical sign. So the longest leg is just going to be the square root of 2 times whatever our x is. So for example, let's say we had a 45, 90 degree right triangle here. Right, each of these angles, when we cut the square, is going to be half of 90, so those are both 45 degrees. And let's say that one of these sides is 3. Right, so if we're trying to find the other sides for this special right triangle, well, we know that the 2 shorter sides are both the same, so the other side is going to be 3. And the hypotenuse is going to be 3, from what we just did, 3 times radical 2. So it's pretty straightforward. So if we're moving from the short side to the hypotenuse, we multiply by radical 2. Now, if we're to go backwards, if we're going to go from hypotenuse to short, we're just going to go backwards in our thinking. So rather than multiply, we're going to divide. So divide by square root of 2. All right. Let's move on to 30, 60, 90. So for our 30, 60, 90, this is an equilateral triangle, which is also equiangular. Right, so what that means is that each of these sides is the same length. So let's say this is x. And equiangular means that all the angles, because the sides are the same, are all the same as well. So if we split 180 degrees into 3 different angles, that means that each of them is going to be 60 degrees. Now, just like we did with that square, let's take that and split it down the middle, but this time we're going to do it vertically. So one thing to notice, when we split this vertically, we end up with a right angle at the bottom. It's perpendicular to the bottom. So what that means is it also splits the bottom part into 2 equal parts. Right, so let's kind of redraw this as one triangle. So, oops, not very nice. Let's draw one triangle out of this. Alright, so notice that this is our right angle. Alright, so all we did was take this triangle here, and we're taking half of the original triangle. This angle here is unchanged, right? We have 60 degrees, that's still 60 degrees. This angle, however, up here, well, we split that triangle in half, so that angle is also half of 60. That's going to be 30 degrees. We know that our hypotenuse is x, right? The length of that side didn't change. But what did change was this bottom part, right? So we said we cut it in half. So this is going to be half of x, or x divided by 2. Now let's try to find the other side. So we could label it C, or we could label it Y. And again, we're going to use the Pythagorean theorem. So Pythagorean theorem. Because we have a right triangle, and because we know that the lengths of the 2 of the sides are x and x over 2. Alright, so notice in this case, our x, our hypotenuse is just x, right? We said that our hypotenuse is always across from the right angle. So then we have x squared there. Now, it doesn't matter which one's a and which one's b, but we're going to say that x over 2 is our b squared, or a squared, sorry. And maybe we should rename this b just so we don't mix it up. So this would be our b, just so it's consistent with this b here. Alright, and what we're trying to do here is we're trying to figure out what b is going to be. So we're going to have to do a little bit more algebra than the last time, but it's not going to be that much. Alright, so let's square this up. So when we square this parentheses, we got to square the x, but we also have to square the 2. Now using algebra, I'm going to move this x squared over 4 by subtracting. And what we get here is b squared is equal to, now keep up with me here, this x squared is not a fraction, but the x squared over 4 is a fraction. So what we're going to do is we're going to say, let me write this someplace else, sorry we're running out of space, but x squared is the same thing as 4x squared over 4. So we're trying to make common denominators with the x squared over 4 so that we can actually subtract it. So again, we took x squared is the same thing as 1x squared, which is the same thing as 1 over 1x squared, and if we multiply by 4 on top and bottom, then we end up with 4x squared over 4. So we didn't change the value of it, we just changed the appearance of it. And then once we get here, well, it's like terms and common denominators. So 4x squared minus 1x squared is 3x squared over 4. So we're going to write that in. And in order to find our b, all we have to do is square root. So let's change our colors here. Now when we square root 3, 3 doesn't have a square root, so that's going to stay in the square root. 4 is a perfect square. Square root of 4 is 2. And then the x squared is a perfect square as well. The square root of x squared is x. Right, so b is going to be the same thing as square root of 3 over 2 x. So now we have everything in terms of x. Alright, so let's take a look at what that might look like in an example. So let's say we have this triangle and we know the short side, right, the bottom part is 4. So if we're moving from the bottom side to the hypotenuse now, we're just going to double that. That's 8. And another way to check it is make sure that the short side is half of the hypotenuse, which you said here, right? Which is true. 4 is half of 8. Now to get from the short side to the medium side, we're just going to do 4 square root of 3 over 2. Right, from what we just said, it's just going to be square root of 3 over 2 times whatever our x is. Oops, sorry. Reverse that. Our x is 8, so we're going to say 8 square root of 3 over 2. And when we reduce this, we see that we have 4 radical 3, because 8 divided by 2 simplifies to 4. Alright, it's a lot. I know some of us have forgotten this from geometry. Some of us maybe didn't quite learn it that well. But it's not something that you need to remember. It's just building an idea for next time. So let's do a couple examples here. So for this one, it says find the missing values. First, we have to recognize, is it a 30, 60, 90? Or 45, 45, 90? So in this case, well, we have a 45 here. We have a 90 here. This one also must be 45 because the 3 angles need to add up to 180 degrees. Alright, so we recognize that it's this one, 45, 45, 90. So what we know about this is, if we know the short side, we know the other side is going to be the same. So x is the same thing, 3 square root of 2. And we also know to get from the short side to the hypotenuse, we're going to take our 3 square root of 2 and we're multiplying it by another square root of 2. So we get 3 square root of 2 times square root of 2 is the square root of 4. The square root of 4 is 2. So y is equal to 6. Alright, so we did what we were asked to do, find the missing values, and we know that x is equal to 3 radical 2 and y is equal to 6, and we're done. Alright, let's do the same thing for this next example. It's asking us again to find the missing values a and b. So step 1 again is we're going to figure out, is it a 30, 60, 90 or a 45, 45, 90? Well, we have a 60 here. We have a right angle here, that's 90. So again, if we're adding up all the angles to equal to 180, then this one's got to be a 30 degree. So we know we have this special right triangle now. Okay, so we're given that the hypotenuse is 10. We know from the notes that to get from the longest side, the hypotenuse, to the shortest side, the one across from the 30-degree angle, we just take half. So A is going to be half of 10, which is 5. So we've done that. So we might even want to make a note that the short is half the hypotenuse. Okay. And the last thing, we're going to say to find b, we're going to do 10 times square root 3 over 2. So the medium side is the hypotenuse times square root of 3 over 2. Or another way to do that is to just say the short side, oops, that's not how you spell short, times square root 3. So whichever one is easier for you guys to remember here. So you can either think of terms of the short side, or you can think of terms of the hypotenuse, and you should be able to go from there. Alright, it's a lot of things that we covered, a lot of ideas we covered, and it's kind of the long way. Some people just teach the rules of it and just go from there, because special right triangles don't always show up all the time, and it's not like we cover them a lot. Like, we do it for a little while in geometry and we kind of let it go. So I just wanted to show you guys what it looked like and the conceptual ideas about how they came up with figuring out the relationship of the sides. Like when we took the square and we cut it in half diagonally, how they figured out all the pieces of our 45, 45, 90. And likewise with the 30, 60, 90, we took the equilateral triangle and cut it in half, and then we figured out the relationship with the sides there. It may be a lot to take in, but do at least know how to transition from one side to finding the next side easily, because that will definitely help you out a lot when we start talking about the unit circle and the angles within the unit circle. So good job. Please remember to take your notes and write down any questions you have so that we can go over them next class. All right, thank you. See you soon.